I don't care. You're guys just yeah, but still, I didn't like make it super hard or anything. And then you'll have like shared squad.
All right, guys. Let's look at some composition. But we're not going to do it with numbers this time. We're going to actually compose functions as a whole. It works pretty much the same way, except you just can't like simplify as much because you don't have the numbers to simplify. Okay? But otherwise, it works the same way. So we're going to look at these three functions. I just picked them randomly. I'm always going to ask you what the names of the functions is. If you haven't figured that out, are, what's this? A parabola shifted down one. What's this? A rational function. So it's got some kind of asymptotes, things like that, right? And this, of course, is a line. All right, we know that. So I want us to find f composed g of x. There's different ways I can say this. I can say f of g of x. I can say f composed g of x. I can say the composite function f of g of x. Okay, it's all the same thing. So what should I do first? I should write it out so I can actually do something, because this tells me it's a composite function. It doesn't show me what to do next. This shows me what to do next. It says put g inside of f, right? So I'm going to be putting the function g, this thing, inside of this thing, wherever there's an x. So I'm going to say f of g, which is this. So I'm just going to do exactly what that says. I'm going to put this into any x value. So it could be more than one, right? We only have one x in the function f, so I'm only going to have to put it in one place. If there's more than one place, you're going to have to put it in those other places too. Does that make sense? So I'm going to be putting it right here. So I'm going to go x, 1 minus x, quantity squared, minus 1. Everybody see what happened there? I just put this thing in there. And now I'm just going to simplify it. So I should square the top and the bottom, so I'll get x squared. When I square the bottom, what am I going to have to do with that? I'm going to have to expand it out, right? So if you're not comfortable with this, do some scratch work over here like this. Remember I told you guys the shortcut now, so I'm going to start using that shortcut. 1 squared is 1, minus x squared is x squared, 2 of the cross terms, plus 2, 1 times negative x. So that's x squared minus 2x plus 1. Okay, if you're having trouble getting this, you need to do this off to the side. Now let's simplify that one little bit more. So how many terms do I have right now? 1, 2. I want them to have the same denominator because I can't work with that easily later on. So what I need to do to fix it, I need to make it have the same denominator, right? So this one is just 1 right now. I need to make it be over that same thing. Is that legal? I have to put it on the top too, right? So I gotta go up here and go x squared minus 2x plus 1, 2. That's how we fix up terms, right? If they don't have the right denominator, we gotta multiply it on top and bottom. That's gonna come up again when we get to trig. Really important. So now they both have that same bottom, so I'm just gonna write it once, because it's a common denominator, and I'll just see what happens on top. So if I distribute that minus, I'll get x squared minus x squared, those are gonna go away, plus 2x minus 1. One more step. So this is going to be, if we cancel those, we're going to just have 2x minus 1 over x squared minus 2x plus 1. Okay, I've written it as a single rational function. So I'm not going to be real picky on like this test. If you have a problem like this, as long as you got to about right here, I'd probably be good for this test, okay? But on the homework, I need you guys practicing through this. If you expect to be good at math, you need to try to go through the whole thing, okay? Does that mean I'm expecting everybody to do that perfectly? Really? Not at this point, at least. Okay. Let's try, oh God, I erased the functions. No! You guys have them down, so we're good, right? So g of f, same functions. Ones that you have on your paper. G of f, so we're going to do g of, what am I going to put in here? What do we have x, what f was? X squared minus 1. So I'm going to be plugging that into g. Oh, I want to write it down. This is not good. G is up here. You guys got to stop me next time. Come on.
No, I was wondering what you were doing.
Okay. Just throw something at me next time.
Okay.
Okay. Okay, how many places am I going to have to put this function guy here? Yeah, I'm going to have to put it in there and there. So x squared minus 1 on top, and I've got a 1, I've got a minus, and I've got an x squared minus 1 on the bottom. Why did I put those parentheses there? Because I've got a minus the whole function right here, right? So I've got to distribute that minus. So be careful with that. So I'm going to get x squared minus 1, distribute the minus, so 1 minus x squared plus 1. So that's x squared minus 1 over negative x squared plus 2. I should consider factoring. I don't think it's going to do much on this one. What could I factor, the top or the bottom? The top. Why? Difference of squares. X minus 1, x plus 1 could be on top. We could really factor the bottom too. I don't think this is going to really get us anywhere, but just consider it. I could pull out a negative and have x squared minus 2. Is that a square number that can be factored with difference of squares? No, but just think about this. I can still factor it with difference of squares.
X minus root 2 and x plus 1.
Aha, very nice. You could still factor it like that. I'm just going through skills that it's nice to have. We may need them at some point. So right there's good. Because notice, does anything cancel? Did that really make it any simpler? No. If we were trying to graph it, at least we'd know that it has vertical asymptotes at negative root 2 and positive root 2. 0 is at negative 1, positive 1. So if we were going to graph it, we'd need to go about it like that, right? Okay. Let's try one more. Let's do f of h. You guys try that one. I think that one's a little simpler. Try f of h of x. Remember h was the line 5x plus 2. Write it down all over again. So try to get f of h and simplify it as much as you can. So what did it turn into when we were done? What kind of function do you get?
Like,
Sesame Street.
what? No, it's not. Schoolhouse Rock. Schoolhouse Rock. Not Sesame School. Elementary school.
Okay, when we do f of h here, we're going to get f of h of x, which means we're going to do f of x, 5x plus 2. So we're going to take that, put it there. So then we're going to expand that out. It's the shortcut, or by writing it like this. So 25x squared, 10x, another 10x, minus, or plus 4, minus 1. So it's 25x squared plus 20x plus 3. That's what you should get. Okay?
Yeah.
Alright, let's look at one application and then I think you guys are
I think we should show how to do the domain and range.
domain and range. And does that, how many of them did it ask you for that on?
I hope you didn't throw.
You erased them.
You didn't throw it.
What did it ask? Where did it ask you?
On 11, and 30 and 32. Just the domain.
Yeah, this is the domain. Yeah. Okay, so if you've got any quadratic, any line, what's the domain? Is there something in there you can put in to break it? No, so the domain's what? All real numbers. Okay? If you have a rational function and you have something like this when you're done, like this is what your answer looks like, what are the things that you cannot put in? -3 and 1. So you put the domain as everything but -3 and 1, just like we did before. If it's, does it have any square root functions on those? Yes, it does. So, or this is maybe something we didn't do a lot of. If you have this, let's say you get your answer and it's the square root of 2x plus 1. I can't have that thing inside be negative, can I? You would get I. So you have to put 2x plus 1. This is something we'll focus on more next year, but I have to make the inside strictly positive or 0. So if you solve that inequality, you get the domain is everything that's bigger than -1/2. As long as you put something bigger than -1/2, that inside stays positive. So it can be okay. So the domain on this one is -1/2 to infinity. Okay, so there's an example to try to help you guys out on that one. Okay. Alright, let's look at one application. Okay. This says that Lisa imports scooters from Italy. Sounds like an extremely lucrative business. So she pays 75 euros for shipping plus a 10% charge, like handling, shipping and handling. Okay. So what we want to do is write a composite function for the total cost. But we don't want it to be in euros. We're going to make it in dollars. Okay. So here's the steps we're going to go through. So that was in euros. We needed to change it to dollars. So that's like one of our functions. That's why this is a composite. There's like two things. Okay. So step one is we're just going to write the euro cost down. So let's call it E of C. So what's the euro cost going to be? I'll make this hard. How much is it going to pay based on what that says? Well, yeah, it's going to be a 0.1 C, 10% of C, right? Plus a $75 shipping rate that's flat. It doesn't depend on how much the thing costs. What else though? There's something else in there. That's the service charge, the handling. That's the shipping. What else is she going to have to pay for, obviously, that you don't want to forget, but it's not mentioned? The scooter, which is going to be what? Use the same variable that's here.
C.
It's a C. So you got C plus 10% of C plus the $75 for shipping. So that was the sneaky part, but you don't want to forget that. Of course, she has to pay for the scooter. She's not getting it for free. Come on. Okay. So we can combine those, right? That's how much C? 1.1 C plus 75. Okay. So there's E of C. That's how much she has to pay for each one in euros. Step two, let's just do the exchange rate. Dollars to euros. And at this time, the exchange rate, there's an exchange table on page 685. So if you guys have a problem or you need the exchange rate, just look at that table on 685, okay? It's probably not current. These books are a few years old, so I'm sure it's not exactly right. So dollars of the cost is the cost divided by 0.77. And I just got that out of the table because on page 685, it says the euro is $0.77, okay? So now, the last thing that they asked me to do is write a composite function. So I'm going to take these and put them together, okay? I want dollars, right? So dollars is going to be on the outside. So I'm going to do D of E of C. So if I plug this function in, which gives me the amount in euros, into this function, it'll give me the amount in dollars. So that's going to be equal to D of this. So I'm going to take that, put it right there for the variable. And I didn't even reduce that, I just said that's it. So that's D of E of C. Yeah, you could reduce it, but it's good enough. So then let's say one scooter costs 1,200 euros. How much does she pay? So how much is Lisa going to have to pay over here to ship that and get it over here? Not really. Yeah, this is like one of those Vespas or something. Yeah. It's not like a Razor scooter. So this is D of E of 1200, so I'm just going to put it in. So 1.1 times 1200 plus 75.77. Let's see. So she has to pay $1,800 for her Razor scooter. Paul says that's not a good deal. Okay. You guys have questions? Have a look at that problem. Is there anything that we're a little bit uncertain about? I think it would have been a little difficult without me going through the example. But, so I think I gave you like 1 or 2 of them, so that should give you a little bit better.